We are standing in the hull of planet Earth, and I am here before a banded iron formation. And the reason that this sample is on display here is that it is the primary evidence that the early atmosphere contained no oxygen. And so that's what I would like to explain to you, the logic behind that. But first, let me describe to you what this is. Obviously, banding refers to the fact that this banded iron formations are layered, and the layers consist of this red stuff, which is basically jasper, a form of silica, and the individual very small grains in jasper are coated with iron oxide, and that's what gives them the red color. And these dark layers are made of the iron oxide mineral magnetite, the formula of which is Fe3O4. The question is, why is it that this sample provides evidence for no oxygen in the early atmosphere? It turns out that, first of all, these samples only exist in the geologic record before about 1.8 billion years ago, or so ago. We don't see them in the relatively young record. And there's a good reason for that. Present-day seawater contains basically no iron. The concentrations are so low, they're almost impossible to measure. And the reason it contains no iron is because as soon as one puts a little bit of iron in ocean water, it immediately reacts with the oxygen in the ocean water to precipitate as iron oxide minerals. So that's probably what happened in the early Earth. This graphic illustrates the process by which we think banded iron formations formed. In the early Earth, there was hot spring deposits driven by volcanic activity, causing circulation of seawater through the ocean crust, and as that seawater moved through the ocean crust, it dissolved some of the minerals in the crust and became enriched in metals, especially iron, and so introduced large amounts of iron into the ocean. So that ocean at that time contained no oxygen. So because it contained no oxygen, it was able to dissolve significant quantities of iron. Eventually, stromatolites appeared on the scene, organisms that engaged in photosynthesis and thus introduced oxygen into the system. The earliest known stromatolites appear in the geologic record about 3.4 billion years ago. So the stromatolites were producing oxygen, but that oxygen was immediately reacting with the iron in ocean water to precipitate the iron oxide minerals that form the banded iron formations. The ocean basically ran out of iron and other things that were removing oxygen from the system, that the oxygen content of the ocean and the atmosphere were able to rise. And we know pretty much when that was because we have means of dating that time. And that rise started about 2.45 billion years ago and ended about 2 billion years ago. In that interval, the oxygen content of the atmosphere increased from essentially nothing to perhaps 1% or so. And it didn't reach its present value of about 20% until the end of the Proterozoic era.